we have different services. For example, semaphore, that is use of semaphore, use of mailboxes, then use of your message queues, and the use of timers. So these are the different services available to solve the problem of resource synchronization and the task synchronization. In last lecture, we have seen what is the resource synchronization problem. That is, if you have multiple tasks and a single single resource like task 1, 2, 3, 4, and you have a single printer as a resource, then it is very difficult to share a single resource by different tasks. So how to solve this problem? So this problem can be solved by using different solutions like semaphores. Then second problem is called as a inter-task synchronization or synchronization between different tasks. That is what is inter-process communication. How task 1 and task 2 will communicate with each other, task 2 and task 3 communicate with each other, or task 3 and task 4 will communicate with each other, or task 1 will communicate with task 2, 3, 4. Okay, so this is what the main or inter-process communication problem. So these kinds of problems can be solved by services like mailbox, message queues, timers, and then pipes, and then events. So there are many solutions available. Out of this, what are the important and related to syllabus? I will cover those particular concepts only. Okay. We have seen the definition of semaphore. So semaphore is nothing but one kind of protocol mechanism offered by the most multitasking kernels, and we have seen the use of this particular semaphore also. So it is used to control access to a shared resource. Then it is used to signal the occurrence of particular event and allows two tasks to synchronize their activity. So this is what the semaphore. In a simple language, semaphore can be treated as a key. Okay, so the task which takes that particular key can continue its execution. So we have seen there are two types of semaphores. Okay, so first is a binary semaphore and second is a counting semaphore. So whenever we have a single resource, you can use the binary semaphores, but if the resources are greater than one, that time you have to use the counting type of semaphore. In the last lecture, we have seen the example of how to use a binary semaphore for the particular assessment of your printer by two tasks, that is task 1 and task 1 to print something by using this printer. Okay, so the procedure to follow the this particular communication is task 1 want to print something, so it will go to this particular semaphore, that is key. If that key is available, the task will take that key, that is task 1 will take the semaphore. Okay, and that means the control of your printer is with a task 1 only. So task 1 will print its whatever the data, that is I am task 1 by using this particular printer, and once this is finished, it will release the semaphore. So that's why this arrow is bidirectional. That is, acquire the semaphore before the start of the task and release the semaphore once it is over. Similarly, when task 2 want to print I am task 2, that time task 2 has to check whether the key is available or not. If the key is available, then it will acquire the key and continue to print I am task 2 by using the printer. Once this task is over, the task 2 will release the semaphore again. That means it will put the key in the its previous place. Okay, so this is what the communication protocol, and this is how you can solve the share resource synchronization problem. Okay, but this is true if you have only single resource. Now there is another type of semaphore called as a counting semaphore. Okay, so I will take this example of memory. Okay, so let consider that you have a 10 memories. This is called as a pool of memory or called as a buffer. So let there is a pool of 10 buffers. That means you have buffer 1, that is 3, or buffer 1 on memory 1, memory 2, memory 3. Likewise, you have 10 memories. Okay, and now if that means right now I have 10 resources available. Are you getting? In the previous case, binary semaphore, there is only one resource, that is a printer. Okay, but now in this example of your counting semaphore, I have more number of resources. Okay, so how many number of resources I have? That is a 10. And what is that resource? That resource is nothing but the memory, or called as a buffer. So how many memories I have? I have 10 memories. So memory 1, memory 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now since I have 10 number of resources, now I have to assign 10 keys. Okay. So this particular shows that since I have 10 resources available, so I can use 10 keys. Okay, and each key is associated with one resource. That is, I have 10 keys. So first key is associated with a memory block 1. The second key is associated with a memory block 2. Third key is associated with memory block 3, likewise. Okay, so I have 10 memories and I have 10 keys, and each key is associated with its own resource, that is a memory. Now this is what called as a counting semaphore. Okay. Now we have to see how your task 1 or 2 or whatever the number of tasks try to get the resources. So for this, here are two functions. These are declared called as a buff request. That is called as buff means buffer request. Okay, and this is a open braces which indicates that this is the function. Similarly, there is another function called as a buff release. So called as a buffer release. Okay. Buffer means memory. Okay, and there is one device called as a buffer manager. Okay, so buffer manager will take care of the proper assignment of the buffer to the task as well as release of the buffer. Okay, so that is what the function of this buffer manager. Then I have two tasks, task 1 and task 2. Okay, so this figure 1 shows the counting semaphore, how it is used in the management of buffer pool. Okay, so this is what the very good example of your counting semaphore, which explains that how your pool of buffers or memories can be utilized properly with the help of the counting semaphore. So I will explain the operation of this counting semaphore. Let task 1 want to use one of the buffer. Okay. Okay, so what is the procedure? Task 1 want to use one of the buffer from this buffers. Okay, so task 1 will put the request. That means it will request buff request. It will initiate the buff request to the buffer manager. Okay, that means task 1 said to the buffer manager that I want to execute my task, so please give me the resource. Okay, there is a memory. Now, what is the function of buffer manager? Buffer manager will check whether any buffer is available or not. So right now, initially, all the 10 buffers are available. So buffer manager will see that the all the 10 buffers are available. That means all 10 keys are available. So that buffer manager will assign one key, that is one buffer, to the task 1. Okay. Now the task 1 will take one of the buffer or memory and it will execute its task. Okay, once task is executed, now your task 1 will call another function called as a buff release. Okay, that means buffer release. So the use of your resources is completed, so it will release that resource. Okay, so this is what the procedure if any task want to assess the counting or multiple resources. Okay, so just remember this. Let's go for the task 2. Now let task 2 want to execute some function or it's want to execute itself. So the procedure again remains same, that is task. Hello.
हा सर, प्राची ऍड करायला बघते पण तुम्ही ऍड नाहीये करून घेतलेला लेक्चरला.
हो का?
हा
ओके, एक परत रिक्वेस्ट पाठवा. हा एक परत पाठवा रिक्वेस्ट. झाली का ऍड? हॅलो, ऍड झाली का?
नाही झालं नाही.
ऍड पेपर आता इथं ऍडमिट रिक्वेस्ट पाठवा वर परत.
पाठवली येते ना बट होत. हा झाली
झाली ना. हा ऍक्च्युली मी ऍटो करून ठेवलेलं आहे. मी ऍडमिट नाही करत. मी तिथं प्लग इन ऍड केलेले, ते ऑटोमॅटिकली तुम्ही आला की ऍड करतो ते. ठीक आहे, म्हणजे मला ते पाठवले की ऍड करून घेतो तो ऑटोमॅटिकली. मला बघायची गरज नाही किंवा अप्रूव्ह करायची गरज नाही तुम्हाला ऍडमिट करायची. ठीक आहे. Okay, so we are going to see the counting semaphore. So the working of counting semaphore is very simple. I have multiple resources here. Memory is, buffer is called as a resource. So I have 10 resources and I have 10 keys. So each key is assigned to each buffer or the memory, and your task try to assess these resources one by one. Okay, so since I have 10 resources, only 10 tasks can use this buffer at any time. Okay, so the procedure again remains same, that task 2 want to assess the buffer out of this 10. So the procedure is same. Task 2 will first call the function buff request. Okay, now this request is given to the buffer manager. Now buffer manager will again check whether any buffer is available or not. If the buffer is available, then it will assign one of the key related to that particular buffer to the task 2. Now once the resource is assigned to the task 2, now task 2 will execute itself, and once it is over, it will again call the function buff release, because the use of your resource is completed. So as a protocol, it has to release its resource, that is a buffer. So once the buff release function is called, that buffer is released from the task 2. Okay, now I have task 1, task 2. Then if I have such a kind of 10 tasks, so at any time your buffer manager can assign 10 keys or 10 buffers to 10 tasks. Okay, but now let the situation that I have 11th task. Okay, now in this case, what happen if all the keys are already taken by all the 10 tasks? So your next task, that is 11th task, has to wait. Okay, because the key is not available. Okay, but this is not the case, because when task 1 takes the buffer, okay, a buffer, and it will execute itself. So it may happen that your number of buffers may be free. Okay, when your 11th task calls the buff request, okay, so that time your buffer may be available. Okay, because you have more number of resources. If the resource is a single resource, that time you may have the problem. But right now, since your number of resources are more, then it is possible that each and every task can get the that particular resource and can execute its own task. Okay, so that is what counting semaphore. You have to just remember that in counting semaphore, you have more than one resources. In this case, memory is a resource. I have 10 number of memories or the buffers, and each buffer or resource having its own keys. That's why if I use 10 resources, that means I have 10 keys. Okay, if I use 20 resources or 20 buffers, I may have 20 keys. Okay, and how to execute the task, that is, each task will ask for the particular resource, whether it is available or not, to the buffer manager by calling the buffer request function. Okay, and then buffer manager will take care of all the resources. Okay, and whenever the task is completed, as a protocol, you have to release that resource, so that another task can take that resource, can execute itself. Okay, so you have to just follow this particular procedure. That is, whenever you want to execute, you call the buffer manager by using buffer request, execute your task, and then call the buff release function. Okay, it will release the that particular buffer. Okay. So this is what counting semaphore. So counting semaphore is used when a resource can be used by more than one task at the same time. So that is what you have to write in the theory. Okay. Then different semaphores can correspond to different shared resource. That is what I had told. That means semaphore 1 is for buffer 1, semaphore 2 for buffer 2, semaphore 3 for buffer 3, likewise. Okay. So for example, a counting semaphore is used in the management of buffer pool as shown in the figure. That is what I just explained. Okay. So here example I have taken, that is, let us assume that the buffer pool initially contains 10 buffers. Okay. A task would obtain a buffer from the buffer manager by calling the buff request. When the buffer is no longer needed, the task would return the buffer to the buffer manager by calling the buff release, and the buffer manager will satisfy the first 10 buffer requests, since there are 10 keys. Okay, so when all semaphores are used, a task requesting a buffer would be suspended still until a semaphore becomes available, because already those semaphores are taken by the 10 tasks, so you don't have any semaphore available. So when a task is finished with the buffer, it acquired, it calls buff release to return the buffer to the buffer manager. The buffer is inserted into the linked list before the semaphore is released. Okay, so that is what the function of buffer manager. So it will assign the required buffer to the task, and also it will maintain the balance of your buffers. Okay, and this is what the explanation to the counting semaphore. Okay. I hope you have understood the counting semaphore. Okay, just remember, you have more than one resources. That means you have more than one keys. That is semaphores. I assign each key to each resource. If I have 10 resources, I have 10 keys. If I have 20 resources, I have 20 keys. Okay, and the procedure will remain same. There are some questions based upon the semaphores that may be asked in the your exam. That is, first question is, what is the advantage of having multiple semaphores? Means why not to use only binary semaphore? Why to use counting semaphore? Okay, why to use counting semaphore? The reason is very simple. Because if you have multiple resources, you cannot use the binary. You cannot use a binary semaphore. Okay, because for each resource you have to assign a separate key. Okay, so the answer is different semaphores can correspond to different shared resources. That's why you have to use multiple semaphores. Second question, how does the RTOS know which semaphore protects which data? Okay, the answer is it doesn't. Okay, so RTOS doesn't know that is which semaphore is assigned to or which semaphore will protect which data. Okay, that means I have 10 buffers, so which key will protect which buffer? So this information is not available to the RTOS. Some of the problems while using the semaphores we have seen last time also. So the first problem is that forgetting to take the semaphore. Okay, then second is forgetting to release the semaphore. Third, you are taking the wrong semaphore. Just say, so if you have more number of semaphore, so it may happen you are taking the wrong semaphores. Then fourth problem is holding a semaphore for too long. Next problem is called as a priority inversion and called as a deadly embrace. So these 2 points are very important: priority inversion and deadly embrace. So I will cover maybe in next lecture. Okay, not right now. I have to cover different points. Okay, so these are the problems. There may be a question on this also. What are the problems with semaphore? Okay, so these are the different problems, but these are the serious problem called as priority inversion and deadly embrace. Okay. So I hope you have understood the semaphore, that is binary semaphore, and also the counting semaphore. Okay. Then we go to the next point. The next point is message mailboxes. Okay. Now, what is message mailboxes? Just right now, I have explained that there are different services for resource synchronization. So, for resource synchronization, application of semaphore is one of the solutions. Okay. Now, how to perform the inter-process communication, or called as a task synchronization? Okay. Task synchronization means it's very simple. Right now I have this lecture. Okay. After that you have another lecture. Okay, so before I or still I complete my lectures, so the next lecture should not be start. Okay, so for this I have to be some synchronization with the next faculty. Okay, so we should have some synchronization in between both of us. Otherwise, what happen? He may take my lecture, or or both will come at the same time. Okay, so these are the problems. So how to solve these kinds of synchronization problem? So these problems, task synchronization problems, can be solved by services like message mailbox and the message queue. Okay, the concepts are very simple. Okay, what is message mailbox and what is message queue? Is it visible? This is your Google Jamboard. It is visible. Hello. Is it visible to?
No, sir.
No, sir. Okay. What I have shared right now. Okay. I think right now it is visible.
Yes, sir.
Okay. So we have a simple concept of message mailbox. So message mailbox concept is very much similar to our postcard boxes. Okay. For example, one person go to that particular mailbox and put the message card into your mailbox. Now this person is called as a task one. Now another person again come to that mailbox and read the mailbox. Now that person is called as a task two. Okay, so the similar analogy can be applied in this message mailbox concept. So task one, I have two tasks, task one and task two, and there is a facility called as a mailbox. Okay, like your postal mailbox. Okay, now whenever task one want to communicate with task two, the task one will post some message into this mailbox. Okay, that is what's shown by this arrow mark. So post the message into this particular mailbox. Okay, and after that task 2 will read the message, okay, from this mailbox, so that task 1 and task 2 can get synchronized to each other. Okay, so whatever information task 1 want to communicate with task 2, now this is possible through this mailbox. This concept is called as a mailbox or message mailbox concept. Okay, now another concept is a message mailbox concept. Now next concept is called as a message queue. Message queue. So what do you mean by queue? Queue means there are more number of mailboxes. Okay. So I will take the same task 1 here. Okay. So I have task 1. I have task 2. And now I have more than one mailboxes. So I have mailbox 1. Mailbox 2, mailbox 3, okay, so I have let n number of mailboxes. Okay. And okay, so now here what happens in the this message queue. So message queue is nothing but the modified version of your message mailbox. In the previous concept you have only one mailbox, but in message queue you have a queue of mailboxes. Okay, that means this is nothing but the memory. Okay, so in the mailbox means it is a single memory. A message queue means you have the queue. Okay, you have a number of memories that are linked together. Okay, so this is memory 1, memory 2, memory 3, memory 4, or I can call as a mailbox 1, mailbox 2, mailbox 3, mailbox 4. Okay, right? That means like your postal mailbox, rather than one box, you have multiple boxes. Okay. Now, what is the advantage of that? You can put multiple messages into multiple boxes, and the multiple tasks can have the access to that particular multiple boxes. Okay, so here task 1 will again do the same thing, that is it will post some message. Okay, it will post some message to the mailbox 1. Okay, and your task 2 can read the message from that mailbox 1. Okay, now if I have more number of tasks, okay, that means if I have task 2, or sorry, let I have task 3 also. Okay, I have task 3. Okay, so if I have task 3, then I can post my message into mailbox 2. Okay, if I task 4, I can post the message from message to your mailbox 3. Okay, and if I have task number 5, I can post my message to the mailbox 4. Okay, now what is the advantage of this message queue is that is more number of tasks can post its message to the mailbox. Okay, and a number of tasks also can read the message from the mailbox at a time, that is simultaneous operations can be done by using this message queue, but this facility is not available with a mailbox, because in mailbox you have only single mailbox there, so only one task can post the message and only one task can read the message. Okay, but how to handle a multiple number of tasks, okay, or how to handle a multiple task, or how to synchronize multiple tasks, so that is again possible by using message queue. Okay, here the number of tasks can post its message into the mailbox simultaneously, and also the number of tasks can read the messages from the same mailboxes. Okay, so this is how you can synchronize your number of tasks to each other. Okay, so this is what the simple concept of message queue and the message mailbox. Okay, I hope you have understood this. Are you okay with this? Have you got the idea of message mailbox and message queue? This is very simple to understand theoretically. Okay, now this is what the theoretical explanation of the message mailbox. Now this is what somewhat more detailed view of the message mailbox. Okay, so here because it is related to your MuCOS 2 OS, so here message mailbox is MuCOS 2 object that allows a task or an ISR to send pointer, variable or message to another task. The same thing, that is I have task 1 and I have task 2, and now this is called as a mailbox. Okay, so task 1 will post some message into this mailbox, and task 2 will read some message from this mailbox. That is what's shown. Okay, now the message can be posted by the ISR also. So here in green color, interrupt service routine can also post the message into this mailbox. Okay, and the same message can be read by the task. Okay, now since this is a MuCOS 2 operating system, so you have number of services. Okay, so what are those services? That means how to manage the mailbox, okay, or message mailbox. So you have different types of call functions for the mailbox management. The first function is called as a creating a mailbox. Okay, because before posting something into the mailbox, first you should have the mailbox. So first function is to create a mailbox. Second function is to delete a mailbox. That means once your work is finished or completed, you can delete the mailbox also by using this function, delete mailbox. Third function is called as a waiting on a mailbox. Okay, that is you have to wait for the message. Okay, then signaling a mailbox. That means if you want to post something into the mailbox, you have to call this function called as a post. Okay, and if you want to read something from the mailbox, you have to use this function, that is writing on a mailbox. Then fifth function is getting a mailbox without waiting. Okay, you can read the your mailbox, okay, without waiting also, okay, because there are certain possibilities that let task 2 want to read the message from task 1, that is from the mailbox, but the problem is task 1 has not put any message into the mailbox. Then in this scenario, task 2 cannot read the message from mailbox. So in this particular scenario, task 2 has to wait for some time. Okay, some time means you have to assign some time, like 5 seconds, 10 seconds, so that task 1 can put the message into the mailbox, and only then you can read the message from that mailbox. Okay. The next function is called as obtaining the status of a mailbox. Okay. That means you have to check whether the message is present in your mailbox or not. That is, whether the message mailbox is empty or it having some data or message. Okay, so you can check the status of your mailbox also by using this function. So these functions are very much similar to for your semaphore management and also the message queue management. Okay, so once you understood message mailbox, you can understand the message queue also, and also you can understand the semaphore management also. Okay, so just give more attention for this lecture. Okay, now just see these are the functions that used in the MuQuas 2. Okay, because MuQuas 2 is a it's a real-time operating system or microcontroller operating system for embedded system, and this is OS and it having its own functions. Okay, now if you understand this, I told that you can understand the semaphore and message queue and most of the MuQuas 2 functions. Okay, that is how it is. So the first question is that how to create a mailbox. Okay, so to create, because before the use of any functionality, you have to create it. Okay, now how to create it? So the function is shown by this arrow called as a OS. Okay, OS mbox create. What is the meaning of this? How to read it? Operating system mailbox create. That means this function, and this is open braces. That means this is the function. So if when I call this function, so this function will create a mailbox. Okay, are you getting? If you want to create a message mailbox, you have to use this mbox create. Okay, this is very much similar to how to create a semaphore. So OS sema create or OS queue create. Okay, so whether before use of your semaphore or message queue, you have to create the semaphore or the queue. Okay, so the functions will be something like this. That is mbox create for creating a mailbox, sema create for creating a semaphore, and OS queue create is a function for a queue creation. Okay. Now second function, okay, try to understand this function. If you understand these functions, then this unit is very simple. Then this function called as a OS mbox post. Okay, so what is the meaning of operating system mailbox post? Means that task 1 want to post something into the mailbox. So whenever any task want to post some message into the mailbox, it will call this function. Okay, that is posting something into the mailbox. So this is done by using OS mailbox post. Okay, similar way, if you want to read something from this mailbox, so you have to call OS, you have to call this particular function called as OS mbox paint. Okay, so operating system mailbox paint function will read the message from the mailbox. So that is how simple these functions are. So post means posting a message of one task into the mailbox, and paint means reading the message from the mailbox and transferring it to the another task. Okay, so just remember this. Post means putting something into mailbox, paint means reading message from the mailbox, and create means you create that functionality. Okay, now there are another functions are also. There is OS mbox accept, OS mbox query. Okay, and as we have seen, ISR can also post the message into the mailbox. Okay, so for this, ISR can also post the message by using OS message box post functions into the mailbox. Okay, and can also accept the contents of your mailbox directly. So that's why this is directional. That is, ISR can post and also ISR can accept. I hope you have understood these three functions importantly: mailbox create, mailbox post, mailbox paint. Now, next point is we have to see this function in detail. Okay, that is how to create a mailbox. Okay, uh, creating a mailbox. Okay, that is done by calling the function os mbox create. Okay, that just right now I have told. Okay, but it having some parameters also. So how to execute this or how to create a mailbox in mucos 2. So this is done by writing this statement called as a operating system event asterisk os operating system mailbox create function, and inside this function you have some message, that is void asterisk message. Okay, so what are these particular parameters that we have to see? Okay, that means we have to see the details of this os mbox create function. So the message is nothing but it is a pointer to a message to deposit into the mailbox. Okay, so you have to create some mailbox. Okay, so this message msj, it is nothing but a pointer to a message to deposit in the mailbox. So it is nothing but the pointer. And now if this mailbox is null, okay, if null mailbox is empty and used for signal occurrence of the event. Okay, and if it is not equal or it is not null means 0. Okay, is not null means the mailbox is used to assess the shared resource. Okay, so that is how this message mailbox function is used, or the meaning of the parameter. Okay, so you have to understood this. Okay, the that is the significance of the function and the detail of this function, that is the parameter details of the functions. Now this function will return two values. One is called as a null value and another is a non null value. Okay, null means 0. So if your mucos2 failed to create a mailbox, uh, the function os mbox create, this function will returns a null character. Okay, indicating that the mailbox is not created. Okay, now if the mailbox is created successfully, this function will return a non-null value. Okay, indicating that the successful creation of the mailbox. So this is also very important. Otherwise, you don't know whether the mailbox is created or not. And if it is not created, you cannot use for the posting the messages into the message mailboxes. Are you okay with this? We have 20 people. Are you okay with this? Counting semaphore I have completed. Okay, then I have explained what is a message mailbox concept. Then I have explained what is a message queue concept. Okay, so message mailbox is used to post some messages from one task to another task, and in this way these tasks can synchronize their operations. Okay, now this is theoretical one. Practically you have to use the message mailbox from the mucos 2. Okay, and that is what I have explained here. So practically you have to write the code to create a message mailbox. So this is what the first function we have seen to create a message mailbox. Now this is the code to create a mailbox. Okay, that means in the practical hours we have to use this code. Okay, so it's very simple. Okay, once you understood how to create a mailbox, you are able to create a semaphore, you are able to create a message queue also. So that is how it is simple. Okay, but you have to understood it properly. So os underscore event asterisk communication mbox. So mailbox is created for the communication. Void main void. Okay. Then OS initialization. So this is the command from the mucos2 for the initialization of mucos2. Okay. So that is given in the comment, that is initialize microcontroller operating system 2 by calling this function OS initialization. Now we have interested in creating a mailbox. So we will create a this communication mailbox by calling the function OS mbox create void, okay, asterisk 0. Okay. So create a communication mailbox. So how to create this mailbox? So com mbox equal to, that means some kind of variable you can declare, let a equal to mailbox create. Okay. And once the mailbox is created, now you can call the function start multitasking. Okay. So it is done by calling the function OS start. Okay. OS start means operating system start, and it will start the execution of different tasks called as a multitasking. Okay, so depending upon the priority of your task, the RTOS will select the task for the execution. Okay, so this is what the code for creating a mailbox. In this, you have to just remember this particular statement. Okay, you have to write this only, OS mbox create. Okay, in bracket void asterisk 0, that will create a communication mailbox. Now, okay. Now we will see the second function called as a deleting a mailbox. Okay, that means let you have finished the use of your mailbox service. Now you want to delete a mailbox. Okay, so you can delete a mailbox by using this function called as a OS mbox delete. Okay, OS mbox delete. So this will delete the message your mailbox. Okay, I will not explain these details right now. Okay. And a very important function, okay, we will go for this one. Okay, and this is very important function. Now how to post some message into the mailbox by using the function operating system mbox post. Okay. That means we have seen we have two tasks, task 1 and task 2, and you have one mailbox. Now task 1 want to post some message into the your mailbox. So how this function is achieved? This particular work is executed by this function called as a OS mailbox post. Okay, post means posting a message from task to mailbox, that we have seen. Okay, now we have to see the internal parameters of this functions. And again, I will say that if you understood this function, you can understand all the functions for semaphore and also the message queue. So we'll go one by one. Okay. So first is E&TC. So this indicates that the microcontroller operating system 2 or mucos2 having its own data types. Okay. It cannot use the data types from the C. With having its own data type. So this indicates that INT indicates that this is a integer type of data, and it's a 8-bit integer. U indicates it is unsigned data. So INT8U means it's a 8-bit unsigned integer data that is used by your creation of your mailbox or posting the mailbox. The next function is OS mailbox post, that is operating system mailbox post means putting some message into the mailbox. Okay, and these are the internal parameters of your functions, that is OS event asterisk p event, that is pointer to the event, and void asterisk message, that is the actual message contained into the mailbox or the particular message you want to post into the mailbox. That is what indicated by this message. So the same parameters are indicated over here also. That is p event is nothing but a pointer to the mailbox to post to. Okay, so it will point to the memory location where you have to actually post that particular message. Okay, and message is nothing but a pointer to the message to send. Okay, so the actual message message to send to the mailbox is pointed out by the MSJ. Okay, or this MSJ variable. Now this is what the OS mbox post. That means this function is used to post the particular message that is written into this MSJ okay, variable, okay, and this p event will point to the pointer at which the message is stored. Okay, now again there are two possibilities of this function. Okay, that is whether the message is properly posted into the mailbox, or it may happen that is that the mailbox is already having some data. Okay, so in this case this function will return some values. Okay, so this particular OS mbox post can return no error. Okay, so if there is no problem while posting your message into the mailbox, okay, so that time it will return the value of no error. If mailbox is already having something into it, okay, that means task 1 has already put some message into the mailbox and that message is not read by another task, so in this case this function will return you the value that is mailbox is full. Okay, so I cannot post into the mailbox because it already contains some data and that is not read by the another task. Or p event is not a mailbox, or p event is a null, or posting a null parameter. Okay, so these are again that is in very much in details. uh, so maybe I will try to avoid this right now. Just remember these two. Okay, if there is a data in the mailbox, it will show that the mailbox is full. If the data is read by the task, then it will show that there is no error and the message get pasted or posted to your mailbox. Okay, so this is very simple function of OS mbox post. Now, once you understood the message mailbox post function, you can understand the this function as well, that is OS mailbox paint. Now, what is OS mailbox paint function? It will read the mailbox, okay, or your any task can read the mailbox by calling this function mbox paint. Paint means read from the mailbox. Now again you have to understand this function. So this function is written as void asterisk OS mbox paint, and it contains some internal parameters, and these parameters are again very much similar to the OS mbox post. Okay, so first parameter over here is OS event asterisk p event, that means pointer to the event. int16u, that means it's a 16-bit unsigned integer data that is declared as a variable timeout, and int 8-bit unsigned integer, which is an error. Okay, that means this function will try to read the message from the mailbox. But now if you observe here is one more parameter called as a timeout. Okay, why timeout? Because let task 2 want to read some message from the mailbox. Okay, but what happened, task 1 has not posted anything into the mailbox, so your task 2 has nothing to read from the your mailbox. So in this particular case you can put a timeout into the task 2. That means you can wait for 5 or 10 seconds so that your task 1 can post some message into the mailbox, and if within 5 to 10 seconds it has posted the message, then it's okay. Otherwise it shows the timeout. Okay, that means now I cannot wait for the message, it will come out of that state. So here internal parameters again the same. This p event parameter shows a pointer to the mailbox to paint to. Now what is timeout? I have just told if the value of this variable timeout is 0, that means this task can wait for the message for a forever. Okay, means still your task 1 will put the message into mailbox. Okay, for that much of time task 2 can wait. Okay, but if task 2 has to perform something very urgent work, in this case it cannot wait for a forever, rather than it will put some time deadlines. Okay, 5 seconds or 10 seconds. Okay, and within that time if the message is received, it is okay. If it is not received, then it shows the timeout and try to execute itself without waiting the message from the task 1. Okay, so which is shown as not equal to 0, that means wait with specific timeout. Okay, now this function will also return some error, that is no error. Okay, so if the message is properly read, then it's okay. Now if the message is not available for a particular timeout, then it will show the error of timeout. Okay, And again, there are 2 or 3 errors that are shown as P event is not a mailbox, P event is not a null, okay, called from ISAR. Okay, so right now just remember these 2 errors. Okay, so if the message is read properly, it shows no error. If the message is not available for in a particular time, it shows the timeout. Okay, so at least 3 functions you should understand: how to create a mailbox, how to post the message, that is OSM, OS mbox post, and OS mbox ped. Okay, now once you have understood the message mailboxes, you can understand the message queue also. Okay, so I have just told that message queues is nothing but a bunch of mailboxes. Okay, so that is what's shown here. This is mailbox 1, 2, 3, 4, 5. Okay, that means more number of tasks can communicate or can post the message into the mailbox, as well as a more number of tasks can read the message from the message queue. Okay, so there is no need to wait for the mailbox to be empty. Okay, so this will make your system fast.